Welcome to my second lecture on polynomials. In this lecture, we will discuss about the relationship between the zeros and the coefficients of polynomials. Consider the standard form of a linear polynomial px equals ax plus b. To find its zero, we will put px equals 0, that is ax plus b equals 0, which gives ax equals minus b and x equals minus b upon a. So the zero of this linear polynomial px equals ax plus b will be minus b upon a. Let us denote this zero by alpha. So alpha is minus b upon a. Consider a linear polynomial px equals 3x minus 4. To find its zero, we will put px equals 0. That is 3x minus 4 equals 0. It gives us 3x equals 4, x equals 4 by 3. So the zero of px equals 3x minus 4 is 4 by 3. Let us denote this zero by alpha. So alpha will be 4 by 3. A linear polynomial has at most one zero. For this linear polynomial px equals 3x minus 4, we will compare it with ax plus b. Coefficient of x is 3, that is a equals 3. A equals 3. The constant term is minus 4, that is b equals minus 4. b equals minus 4. We have seen the zero of a linear polynomial is alpha equals minus b upon a. Here the left hand side is alpha, which we have found out to be 4 upon 3, which is the zero of this linear polynomial. And right hand side, which is this minus b upon a, we will replace this b by minus 4 because b is minus 4 here. So minus of minus 4 will be 4 and the RHS will be 4 by 3. Here the left hand side alpha is 4 by 3 and right hand side, which is minus b upon a, is also 4 by 3. Hence, this is the relationship between coefficients 3 and minus 4, 3 and minus 4, and the 0, 4 by 3. Consider the standard quadratic polynomial px equals ax square plus bx plus c. Coefficient of x square is a. Coefficient of x is b. And the constant term is c. Let its two zeros be alpha and beta. We have the following relationships between the two zeros alpha and beta and the coefficients a, b and c of this polynomial. We have sum of two zeros alpha plus beta equals minus b upon a, and product of two zeros alpha beta equals C upon A. Now we will verify this relationship, and for that we will consider a quadratic polynomial px equals x square plus x minus 6. To find its zeros, we will put px equals 0, that is x square plus x minus 6 equals 0. We will find factors of this quadratic polynomial, which are x plus 3 and x minus 2 equals 0. It gives us x equals minus 3 and x equals 2. The zeros of px, x square plus x minus 6 therefore are minus 3, which is this, and 2, which is this. We will denote these zeros by alpha and beta, so that alpha will be minus 3 and beta 2. The two zeros of this quadratic polynomial px equals x square plus x minus 6 are alpha equals minus 3 and beta equals 2. Coefficient of x square is 1. That is a equals 1. Coefficient of x is 1. That is b equals 1. The constant term is minus 6. That is c equals minus 6. We will verify the relationship between the zeros minus 3 and 2 and the coefficients 1, 1, minus 6. Number 1. Sum of the zeros alpha plus beta equals minus b upon a. Left hand side alpha plus beta will be minus 3 plus 2, which is minus 1. Right hand side minus b upon a will be minus 1 upon 1, which will be minus 1. Here, since left hand side and right hand side both are equal to minus 1, our first relationship alpha plus beta equals minus b upon a is verified. Second relationship is product of zeros alpha beta equals c upon a. Left hand side is alpha beta, which will be minus 3 multiplied by 2, which is minus 6. Right hand side is c upon a. C is minus 6, a is 1. So it gives us minus 6. Since left hand side and right hand side both are equal to minus 6, our second relationship alpha beta equals c upon a is verified. Consider another quadratic polynomial px equals 6x squared minus 13x plus 6. To find its zero, we will put px equals 0. That is 6x squared minus 13x plus 6 equals 0. We will factorize this quadratic polynomial as 2x minus 3 and 3x minus 2, which gives us x equals 3 by 2 from this factor and x equals 2 by 3 from this factor. The zeros of px equals 6x square minus 13x plus 6 are 3 by 2 and 2 by 3. Let us denote these zeros by alpha and beta so that alpha equals 3 by 2 and beta equals 2 by 3. The two zeros of this quadratic polynomial px equals 6x square minus 13x plus 6 are alpha equals 3 by 2 and beta equals 2 by 3. Coefficient of x square is 6. That is a equals 6. Coefficient of x is minus 13. That is b equals minus 13. The constant term is 6. That is c equals 6. We will verify the relationship between the zeros and the coefficients of px. For that, we will provide the values of zeros and coefficients for ready reference. We have alpha equals 3 by 2, beta 2 by 3, and coefficients a 6, b minus 13, c 6. Now first, sum of the zeros alpha plus beta is minus b upon a. We will write the LHS alpha plus beta equals 3 by 2, which is alpha, plus 2 by 3, which is beta. It gives us 13 upon 6. Now this 13 upon 6 we will write in the form minus b upon a as minus of b, which is minus 13, and see here b is minus 13, upon 6, which is a, and a is 6. Now RHS is minus b upon a, which is this. We will write the value of b minus 13, which is this, upon a, which is 6. Here we observe that both LHS and RHS have same value. Therefore, we can say that alpha plus beta equals minus b upon a is verified. Number 2, product of the zeros alpha beta, which is c upon a. We will write the left hand side alpha beta, where alpha is 3 by 2 and beta is 2 by 3, and it gives us 1. Right hand side will be c upon 2. C is 6, a is 6, which gives us 1. Here, left hand side and right hand side both are equal to 1. Therefore, we can say that the relationship alpha beta equals c upon a is. Consider the standard cubic polynomial px equals ax cubed plus bx squared plus cx plus d. Here coefficient of x cubed is a, coefficient of x squared is b, coefficient of x is c, and the constant term is d. Let its three zeros be alpha, beta, and gamma. Now we have the relationship between the zeros alpha, beta, gamma and the coefficients A, B, C, D as number 1, sum of the zeros alpha plus beta plus gamma is minus b upon a. Second, product of the zeros alpha, beta, gamma is minus b upon a. And third, sum of the product of zeros taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha equals c upon a. To find the zeros of the cubic polynomial px equals x cubed plus 2x squared minus x minus 2, we will put px equals 0, that is x cubed plus 2x squared minus x minus 2 equals 0. Sum of all the coefficients equals 1 plus 2 minus 1 minus 2 will be 1 minus 1 0 and 2 minus 2 0. So sum of all coefficients is 0, which implies that x plus 1 is one of the factors of this polynomial px. For other two factors, we will do synthetic division. For that, we will put x plus 1 equals 0, which gives us x equals minus 1. We have x equals minus 1. Now we will write coefficients of px equals x cubed plus 2x squared minus x minus 2, which are 1, 2, minus 1, minus 2. For doing synthetic division, we will write these four coefficients in a horizontal row like this: 1, 2, minus 1, minus 2. We will draw a horizontal line like this, and a vertical line here, and another horizontal line, leaving a space in between. After that, we will write this minus 1 here. We will pull down this one and write over here. Now 1 multiplied by minus 1 will be minus 1, which we write here. 2 minus 1 is 1, which we write here. 1 multiplied by minus 1 is minus 1. Minus 1 minus 1 is minus 2. Minus 2 multiplied by minus 1 is 2. And minus 2 plus 2 will be 0. Now this 0 is the remainder which we get after dividing this polynomial by x plus 1. Since we get the remainder as 0, x plus 1 is a factor of this polynomial. For the remaining factor, we will use these three coefficients. Since here there are three coefficients, the factor will have degree 2. It will be a polynomial with degree 2. So the second factor will be, for 1 we write x squared, for this one we write x, and for minus 2 we write minus 2, the constant term. Now this is a quadratic polynomial which we can easily factorize and write x minus 1 multiplied by x plus 2. So the factors of px equals x cubed plus 2x squared minus x minus 2 will be initial factor x plus 1, which we have already found out, and the two factors which we have just found out, these two factors, x minus 1 and x plus 2. Now from these factors we will write the zeros of this polynomial, and its three zeros will be minus 1 from this factor, 1 from this factor, and minus 2 from this factor. We will denote these zeros as alpha equals minus 1, beta equals 1, and gamma equals minus 2. Now we will verify the relationship between the zeros and the coefficients of the cubic polynomial x cubed plus 2x squared minus x minus 2, whose zeros are alpha equals 1, beta equals minus 1, and gamma equals minus 2, and the coefficients are a equals 1, b equals 2, c equals minus 1, and the constant term d is minus 2. First, we will verify sum of the zeros, that is alpha plus beta plus gamma equals minus b upon a. We have left hand side alpha plus beta plus gamma equals alpha is 1, beta is minus 1, and gamma is minus 2. 1 minus 1 is 0. So what we get in LHS is minus 2. Now RHS equals minus b upon a. We have b equals 2 and a equals 1. It gives us minus 2. Now since the right hand side of these two expressions is same, the relationship alpha plus beta plus gamma equals minus b upon a is verified. We will rewrite the values of alpha, beta, gamma and the coefficients a, b, c, d for ready reference. Second relationship is product of zeros, that is alpha, beta, gamma is minus d upon a. The left hand side will be alpha, beta, gamma, which is this, which is 1, which is alpha, multiplied by minus 1, which is beta, and minus 2, which is gamma. So it will be 2. Right hand side will be minus d upon a. D is minus 2 and a is 1. So it will be 2. Since both LHS and RHS are equal, our relationship alpha, beta, gamma equals minus d upon a is verified. Third relationship is sum of the product of zeros taken two at a time will be alpha beta plus beta gamma plus gamma alpha equals c upon a. We will put the values here. Left hand side will be alpha beta plus beta gamma plus gamma alpha. Putting the values 1 for alpha, minus 1 for beta, minus 1 for beta, minus 2 for gamma, minus 2 for gamma, and 1 for alpha again. It gives us, this gives us minus 1, this will be 2, this will be minus 2. 2 minus 2 will be 0, and we get LHS equals minus 1. Now RHS is C upon A. C is minus 1 and A is 1. It gives us RHS equals minus 1. Since both LHS and RHS are equal, our relationship alpha beta plus beta gamma plus gamma alpha alpha beta plus beta gamma plus gamma alpha equals C upon A is verified. Consider another cubic polynomial Px equals x cubed minus 27x plus 54. In this polynomial, the square term is absent. Therefore, we will rewrite this polynomial as Px equals x cubed plus 0x squared by writing the coefficient of the square term as 0, minus 27x plus 54. Putting Px equals 0, we will write x cubed plus 0x squared minus 27x plus 54 equals 0. Now, coefficient of x cube is 1 here, and the constant term is 54, and plus minus 3 and plus minus 6 are the factors of 54. So by trial and error, we will find P of minus 6, which will be minus 6 cube by substituting minus 6 for x, replacing minus 6 for this x. It gives us P of minus 6 equals minus 6 cube is minus 216, minus 27 multiplied by minus 6 is 162 plus 54. 162 plus 54 is 216, and minus 216 plus 216 gives us 0. So since P of minus 6 is 0, it implies that x minus minus 6, which is this, that is x plus 6 is a factor of Px. By another trial and error, we will find P of minus 3, P of 3, which will be 3 cube minus 27 multiplied by 3 plus 54. This gives us 27 minus 81 plus 54, which will be 27 plus 54, 81 minus 81, that is 0. So P of minus 3 equals 0 implies that x minus 3 is a factor of Px. Now the three factors of the cubic polynomial will be x minus 3, x minus 3, which are the two equal factors, and third factor will be x plus 6. Therefore, the three zeros of this polynomial px will be alpha 3, beta 3, and gamma minus 6. And the coefficients of px will be a equals 1, b 0, c minus 27, d 54. Now we will verify the relationship between the zeros and the coefficients. For that, we will provide the values of the zeros alpha 3, beta 3, and gamma minus 6, and the coefficients a1, b0, c minus 27, and d 54. Number 1. Sum of zeros is alpha plus beta plus gamma, which is minus b upon a. We will write the LHS alpha plus beta plus gamma equals 3, because alpha is 3, plus 3, beta is 3, minus 6, gamma is minus 6. This gives us LHS equals 0. Now RHS, which is minus b upon a, b is 0, a is 1. This gives us RHS equals 0. Since LHS and RHS both are equal, we can say that the relationship alpha plus beta plus gamma equals minus b upon a, which is this, is verified. Number 2. Product of the zeros equals alpha, beta, gamma equals minus d upon a. We write the LHS alpha into beta into gamma, where alpha is 3, beta is 3, and gamma is minus 6, which will be minus 54. We will write the RHS as minus d upon a, where d is 54 and a is 1. This gives us RHS equals minus 54. Since both LHS and RHS are equal, we say that the relationship alpha, beta, gamma equals minus d upon a is verified. The values of alpha, beta, gamma and the coefficients a, b, c, and d have been provided once again for ready reference. Third relationship is sum of the product of zeros taken 2 at a time, which means alpha beta plus beta gamma plus gamma alpha equals c upon a. We will write the left hand side as alpha beta plus beta gamma plus gamma alpha, which will be alpha is 3, beta is 3, gamma is minus 6, and alpha is 3 again. So this works out. This is 9, this is minus 18, this is minus 18, and this gives us left hand side as minus 27. Now we will write the right hand side, which is c upon a. We have c equals minus 27 and a equals 1, and this gives us RHS equals minus 27. We see that left hand side and right hand side both have equal values. Therefore, we can say that alpha beta plus beta gamma plus gamma alpha equals c upon a, which is this relationship is verified. In this video, we have discussed the relationship between the zeros and the coefficients of a polynomial. In the next lecture, we will discuss how to form a quadratic polynomial or a cubic polynomial from the given zeros. If you like this video, please click the like button, subscribe this channel, share this video with your friends and relatives. Thanks for watching. Keep watching Number Collage.